All right, you guys, in this lesson, we are actually going to now be taking all of our knowledge about integer exponents and rational exponents, put them together to be able to solve a few more complex questions. We're going to begin with easy examples, and then we're doing 10 in total, and then we're going to get to more complicated ones. Oh, come on down. All right, for question number 1, we are going to begin by applying the rule where if you have a power and you have a fraction, you're going to take that power and multiply it to both of the other powers in the numerator and denominator. So this times -2 and this times -1. When you do that, you're going to get b to the power of -2 times -3 is 6 over b to the power of -1 times -3 is just a 3. And then you can use power laws to finish solving this question. So same base, and they're divided. So we're going to subtract the exponents, and we're going to get b to the power of 3 as our final answer. Not too bad, right? We're starting off really nice and basic. For the next question, we have x to the power of -1 and y to the power of 0, and it's all to the power of -3. So again, we're going to take that -3 and we're going to multiply it to the -1, and we're going to multiply it to the 0. When we do that, we're going to get x to the power of -1 times -3 is just 3, and y to the power of 0 times -3 is just 0. Anything to the power of 0 is a 1. So when we reduce or simplify this, the only thing we're left with is x to the power of 3. No y's at all. So it just disappears, becomes the number 1, which you don't have to write. Yeah. Okay, on to question C. So I have a strategy when I'm solving this question. What I like to do is I almost think of it like an onion. I look at the innermost part of the onion and then work my way out. So I'm going to begin over here, and I'm going to try to simplify this as much as I can before I even deal with the -1. If you guys remember from last class, I had told you that if you have a negative exponent in the numerator, to make it positive, you can move it to the denominator. And if you have a negative exponent in the denominator, you can move it to the numerator and it becomes positive. So here, if you take a look, we have 3a to the power of -1. And if I move that entire thing to the denominator, it's going to become 3a to the power of just 1. And then I have a to the power of -2. And if I move that to the numerator, it's just going to become a squared. So I'm going to do this. By the way, there are probably 4 or 5 different ways to approach this question. I'm just showing you one of them, but there's many different ways to do this. So let's try that. So my a squared is now going to come to the numerator. The 2 stays in the denominator. And then 3a to the power of -1, it's going to move to the denominator and just become 3a to the power of 1. So I'll do it again. In my numerator, I'm moving the a to the power of -2. And when I do that, it becomes a squared. This 2 over here doesn't go anywhere. It's going to remain a 2 in the denominator. And the 3a to the power of -1 is going to go to the denominator and become 3a to the power of 1. And all of this is to the power of -1. Does that make sense? Okay. Tell me which part. Ben? Don't touch the coefficient, exactly, yeah. I'm going to continue to solve what's inside of the bracket because I see I have 2 times 3a in the denominator, right? So I can keep the a squared at the top, and this can just become 6a all to the power of -1. And I can actually use power laws over here. So I have a squared and I have an a at the bottom. A 2 take away 1 is just the 1. So this is actually going to simplify to be a over 6 all to the power of negative 1. To finish off the question, if I have a negative exponent, to get rid of it, I just take the reciprocal of the fraction and it becomes positive. So my final answer is just going to be 6 over 8. Now, what are some other things you could have done? Well, if you have a negative 1, you could have actually started off by just flipping everything right away, and then the negative 1 would have disappeared and then solved it that way. Or you could have distributed the negative 1 to every single term. Like I said, there may be 4 or 5 different ways to do this. Pick whatever you want. Eventually, if you're doing all the steps correctly, you will reach the correct answer. B. So pay very close attention to question D, because like I said, it's a little bit tricky. I'm first, again, going to look in the innermost bracket, and I'm going to see what's happening here. So I have x to the power of 1 times y to the power of n all over, and see this 2n? I'm going to go ahead and distribute it to both of the terms inside of the bracket. So this is going to become x to the power of 2n times y to the power of 2n. And all of this is to the power of 2n. So all I've done in this question is I've taken the denominator and I've distributed the exponent 2n to each of the terms x and y. Make sense so far? Okay, now what I'm going to do is I'm going to use my power laws. So I have a couple of x's here, I have a couple of y's over here, and I know when the bases are the same, I can go ahead and subtract the exponents. So I'm going to choose to do this. When I do that, it's going to become x. You can't really subtract 1 and 2n, so it's just going to be 1 subtract 2n times y. You can subtract n. What's n subtract 2n? Negative n. All to the power of 2n. Now that I've kind of simplified the inside of my bracket as much as possible, I'm going to take this 2n and I'm going to multiply it to this, and I'm going to multiply it to this. So when I do that, I'm going to get x to the power of 1 times 2n is 2n. Negative 2n times 2n is negative 4n squared times y. Negative n times 2n is negative 2n squared. Are we allowed to have a negative exponent? We can't. So I actually want to rewrite this to become a positive exponent. All that means it's going to be 1 over y 2n squared. So when you rewrite it, it's actually going to be x to the power of 2n minus 4n squared all over y to the power of 2n squared. I'm going to say that's a pretty tricky example, actually, because it's not messed up, but it's a little tricky. Sarah? Okay, you guys are trying question E yourselves, because I think it's very straightforward. It's just power laws. In fact, this is more grade 9 stuff. What am I doing? It's supposed to be 5 minus 28 over 20, which is negative 23 over 20. Yes. Just a little bit of fraction work. M is equal to negative 23 over 20 is what I'm getting. And then remember, you can't have a I'm just showing you guys two different ways to write a question like this. So by the way, when you do the fraction work, 1/4 take away 7/5, I got -23/20. Did you guys get that as well? Yeah. We can't have a negative exponent, so you have to write it as 1/m to the power of 23/20. And another way to write it, I just want to show you both ways. Either of those is correct. But when you have a numerator of a 1, you can rewrite it as such. Okay, that was really straightforward. Let's go on to question F. Question F is a lot more complicated because now we have today's new lesson, or actually technically yesterday's, because we were supposed to do it over 2 days. And we have to change all of these radical forms to exponential forms. So we're going to take it one step at a time. Let's look at the numerator. The numerator is going to be p to the power of what? The index is 5. There's a little 1 over here, so it's going to be 1/5. Yeah. Over. And the denominator is going to be p to the power of, where's it? 2/3. Good. All to the power of 4. Again, my strategy is I always like to simplify the brackets first, like inside. I follow BEDMAS before I multiply the 4. But either or you would get the right answer. So I'm going to just go ahead and figure out what 1/5 subtract 2/3 is. And when I do that work, I get -28/15. Did you guys get that as well? Yeah. So you can rewrite it in two different ways. You can write it as 1/p to the power of 28/15, or you can rewrite it as 1/p all to the power of 28/15. But it gets exciting. All right, question G is a little bit intense. Let's look at everything that's happening in question G. So now I can use my favorite green. We have 25x to the power of a half times bracket 8x squared to the power of 1/3. So I know that one of the things I'm going to have to do is I'm going to have to take that 1/3 and I'm going to have to distribute it inside of this bracket. And then in the denominator, I have 40x to the power of 1/6, all to the square root sign. Let us rewrite this a little bit. So we have 25 times x to the power of a half times 8 to the power of 1/3 times x to the power of 2/3. I'll pause here just to see so you can see what I did and ask me questions if you have them. So 25 times x to the power of a half, nothing changed there, I just kind of separated them, times 8 to the power of 1/3, because I'm taking the 1/3 and distributing it inside the bracket, and then x to the power of 2/3 because I'm multiplying the 2 and the third. Does this make sense? Everyone see what I did here? Okay, let's keep going. All over 40 times x to the power of 1/6. And then a big square root sign that I will just add later, but you guys just make sure you I want to add it later because I feel like I will make it too messy. That's not too bad. Okay, if you notice this question, you have a bunch of coefficients, you have a bunch of x's, and all of the x's are x's, so you can use a whole lot of power laws. So let's keep going and rewriting this. I'm going to have 25 times, what can I change the 8 to make it a different power? Yep. Perfect. So I'm going to make it 2 to the power of 3 all to the power of 1 over 3 times, if I have x to the power of a half times x to the power of 2 over 3, I can use power laws and add those exponents together. So on a rough sheet of paper or somewhere on the side, you're going to go a half plus 2 over 3 and figure out what that is. So when I do the math, I get 7 over 6. Okay, so I've done two things here. I've changed the 8 to another base, so I can try to simplify that exponent a little bit. And I've used power laws for x to the power of a half and x to the power of 2 over 3, and I get x to the power of 7 over 6. All over 4 times x to the power of 1 over 6. And this whole thing needs a big square root sign. Yeah, because the question has it. Okay, we keep going. We have 25. What is 2 to the power of 3 to the power of a third going to give us? Just a 2. So just to save some steps, 25 times 2 is going to give me 50. Over 40. I can use more power laws for this part right here, where I have x to the power of 7 over 6 and x to the power of 1 over 6. Because I know 7 over 6 minus 1 over 6 is 6 over 6, which is just the number 1. So all of that is actually going to reduce so nicely to give me x to the power of 1. And then we still have our big square root sign over here. We're not done yet. Can I reduce 50 over 40? Yeah, I can reduce it to 5 over 4. So I actually end up getting 5x over 4. And I don't know if you know this, but if you have a radical sign and a numerator and a denominator, you can actually split it up so that you give it to the numerator and denominator. And the useful part of this is we can actually take the square root of 4 to give us just the number 2. Bea? All right, you guys, 3 more examples. Let's try question H. For question H, we are going to change everything that's in radical form into exponential form. So I'm going to begin by the first is a square rooted. That's going to become x to the power of a half times the next x, which just has a 5. Technically, all of these indices, all of the indexes here are 2's, right? So if I change that to an exponential form, it's going to be x to the power of 5 over 2. All over x to the power of 3 over 4. Because the index is a 2. Remember the lesson we just did before this? Exactly. If there's nothing, it's a 2. So it's 5 over 2. And all of this is also going to be to the power of something. Technically, if you pretend like there's like nothing in here, this is a 1. So it's going to be to the power of 1 over 3. So sorry, Sarah, did I see your hand up? Kind of? Okay. Now look at the inside. All the bases are x's, so we can use power laws and simplify it completely. To do that, the first part is going to be a half plus 5 over 2, which is just 6 over 2, which is just 3. So this is going to be x to the power of 3 all over x to the power of 3 over 4 all to the power of 1 over 3. Marzouk, did this answer your question? Okay. I'm going to just solve this on the side. So 3 subtract 3 over 4. That's going to be 12 take away 3 over 4, which is going to be 9 over 4. I know I'm doing that part really fast, but really it's just fraction work. So it's going to be x to the power of 9 over 4 all to the power of 1 over 3. Yes. I added the exponents together, because see how the bases are the same? When the bases are the same, you can add the exponents, a half plus 5 over 2, same denominator, so it's just 6 over 2, which is just a 3. Then I subtracted the fractions, 3 subtract 3 over 4, and I got 9 over 4. And now I just take a power of a power. So when I multiply those, and I reduce them, I'm just going to get a x to the power of 3 over 4 as my final answer. I guess if you're someone who likes to write down the different steps, the steps would be, if something is in radical form, always change it to exponential form. That's really important, because you can't really do anything in radical form. And then just take it like numerator and denominator at a time and just go slowly and like peel away at it, see what you can get. Marju? I don't know. It's just a different form. Yeah, like in terms of my math knowledge, I can't think of like the usefulness of it. Yeah. I just added a half plus 5 over 2. Oh. All right, question I and J. So, if you understood question H, I is very similar to it. If you want it, you can go ahead and try it yourself, and I'll start to put the answers up. But, try and challenge yourself and look up only at the end to see if you can get it. But question I is really similar to what we just did. So try it and then see if you get the same answer as me. So all of your fraction knowledge from grade 9 or up till grade 9 is all coming back now. And over here, I'm going to have 9 over 4 minus 1 over 2, which is the same as 2 over 4. That'll be 7 over 4. So it'll be x to the power of 7 over 4, all to the power of 2 over 5. And when I reduce this, it'll just be x to the power of 7 over 10 as my final answer. All right, for this last question, all right, let's just solve it. So we have, in the numerator, I'm gonna kind of break it down just to see what's happening. We have 64 times x to the power of 9 times y to the power of 6 times z to the power of 3, all to the power of 1 over 3, because my index is 3 and there's a little 1 over here technically, so you put those together. And then in my denominator, I have 8 as my coefficient, and I'm going to take this 1 over 3 and I'm going to distribute it to everything inside of the bracket. Okay, so when I do that, 9 times a third is just going to be x to the power of 3, and 3 times a third is just going to be to the power of 1. So I've made a little bit of progress. I kind of cleaned some things up, and I started to solve the denominator. So pause here, Bea. No, because there's a 1 over 3 there. So that exponent means you can't distribute the coefficient into the bracket. It's like, when you were learning, stuff like this, you can distribute it there. But as soon as you have a number here, you can't distribute the coefficient any longer. Oh. You can't distribute the coefficient inside. All right, now what I'm going to do is I am going to take this 1 over 3 and I'm going to apply it to every single one of these terms. And while I'm doing that, I'm also going to change the 64 to something. So we have a couple of options for 64. What do you think we should change the 64 to? 2 to the power of 6, 4 to the power of 3, or 8 squared? Yeah, 4 to the power of 3 would be the best option. So I'm going to change the 64 to 4 to the power of 3, and that's going to be all to the power of 1 over 3 times 9 times 1 over 3 is just a 3, so that'll become x to the power of 3. 6 times the third is just 2, so it's going to be y squared. And 3 times the third is just a 1, so it'll be z to the power of 1. Okay, so all I'm doing is I'm taking the 1 over 3 and I'm applying it to every single term. And then really, you can't really do anything in the denominator right now, so it's just going to be 8 times x to the power of 3 times y to the power of 1. Okay, 4 to the power of 3 all to the power of third is just going to become a whole number of 4. And this is an 8. We can use a whole bunch of power laws, you guys. We have x to the power of 3 and x to the power of 3. Those are just going to cancel out, because when you have the same thing at the top and the bottom, you can go ahead and cancel it out. Y squared over y1 is going to give me just a y1, and this is going to remain z1, and we're just going to have an 8 at the bottom. And then finally, we can deal with the fraction. So 4 over 8 is just a half. Our final answer is going to be yz over 2. Okay, so I'll just pause here, see if it made that the school is so messed up. So you guys, that is our 10th example. You have a whole bunch of questions to do now. So I'm going to show those questions to you. It's handout A. And for you guys at home, I'm going to just show you each page at a time. So this is page 1. By the way, the solutions are all on the bottom right-hand side. So make sure you check your work as you go along. And there are 3 pages, so lots of questions to do, but I don't see you tomorrow, and then you have the weekend as well. Here is page 2. And then here is page 3. Page 3 has the more challenging stuff, like more of what we did in class today. Okay, and that's the end.